The Gleason map, the farther you get up to the our ice wall, it's distorted because it's a projection of the globe,
So
right?
what you're telling me is that the flat Earth map is not accurate because it's a projection of the globe? So you agree that the Gleason map does not accurately represent the shape of the Earth?
I would say it doesn't accurately represent the depictions of the land masses.
All right, which flat Earth map do you want?
Just pull up the Gleason map, man. Oh, finally. Oh my lord.
NNV, how's it going?
Oh, what's up, man? So
What should I call you, by the way?
You can just call me Nick. My name is Nick.
Nick.
So
All right, Nick.
I was watching your one second. I'm gonna set my camera up and get a
Nick,
shirt
what
on.
shape do you think the Earth is first?
Oh, I know for 100% fact that the Earth is non-rotating. It's not curved, and it is topographically flat. But
Great.
1 second, let me get a shirt on so I can set my camera up.
I mean, you don't have to turn on your camera if you don't want to. Like,
Well, I'm gonna pull up some images and stuff. And
okay, just know that I can't make you big, right?
okay. I did not know that.
Yeah, so I'm streaming on 3 platforms, and so if I make you big and you show something, that only TikTok will see it, and it will make no sense what we're talking about on the other platforms.
Yeah, that makes sense because you're streaming from your computer.
Yep.
But have you ever took a look at Pete Gaspard, the Guinness Book of World Records longest photo over 270 miles?
Yeah, I've heard about this. Yeah.
So it has an observer height from where they're standing. I think it was on top of the Pyrenees or looking at the Pyrenees, and 9,000 foot observer height, looking at Pete Gaspard, which is 9,135 feet, over 270 miles of distance. If you go enter them 3 numbers in the Earth curve calculator, you could actually turn the refraction up to fucking 3. And you are still noticing is hidden under 9,000 feet of curvature with the refraction up around 3. And at 0 refraction, because 1, it's a silhouette, and refraction cannot happen in the atmosphere.
So let's do
according
this.
to Snell's law. Yes.
Wait a minute. To be clear, we'll have to talk about Snell's law in a minute. But so what was the name of the shot?
Just look up Guinness Book of World Records longest photo Pete Gaspard.
Yeah. Okay, I found it.
There's a couple different ones. 1 second. I think I could maybe pull it up.
Yeah. So I actually found a website. I think this is the website owned by the guy who took it, who explains how he took it and what conditions were necessary. Yeah, here you go.
Yeah, I'm very aware.
Yeah. So you've seen his website, right? Here.
Oh yeah, I've seen that exact same thing right there.
Yeah.
Yep.
So I mean, this is cool. So it's 443 kilometers from Finisterre, the Pyrenees, and to Pete Gaspard in the Alps. This is taken on a very specific day. 443 kilometers. Cool. Some pictures and illustrations, fine. This is the photograph with the line of sight. That's the picture with the wide angle, fine. He says, I thought I saw it somewhere on here. Refractive favorable circumstances allowed to view some other peaks, even that more distant than the Barre d'Écrine. So he's clearly saying that there was refractive favorable conditions that allowed them to see so far.
Exactly. This is where we always lead when we go to talk about this picture. Is one, it's a silhouette. So when you impose refraction about the absence of light, we're going to have some big issues. But anyways,
it's the exact same thing. Oh, where'd you go? I can't see your thing anymore. Your icon anymore.
1
It's
second.
fine. It's not necessary. It's just,
The fuck is this? But anyways, so refraction cannot happen in a one isotropic medium.
Good thing the atmosphere is not isotropic.
Yeah, that's what I'm saying is that Snell's law states that refraction needs 2 isotropic mediums to occur. When you stick a pencil in water, look up Snell's law, bring up Snell's law. Just look up Snell's law.
Are you familiar with the differential version of Snell's law?
When it's applied infinitely to the atmosphere? Yes. That makes no sense.
Just the differential version of Snell's law. This is a thing that you can demonstrate in a laboratory, by the way.
Yeah, so I'm going to explain what you guys...
I'm going to show you a physics textbook.
Yes.
Here's a physics textbook.
I think I have the physics textbook. But anyways...
Yeah, here you go. Here's the physics textbook. Here's the differential version of Snell's law.
Yeah, and so what they do is they apply it infinitely to the hot and cold particles, the different density variants, the different incidences, angles of incidence.
So they're using calculus, yeah.
Yes. So what I'm trying to let me speak for 30 seconds.
Mm-hmm.
When you're looking 270 miles across
Mm-hmm.
the mountain peaks, you are claiming that the hot and cold particles are stacked so evenly it creates a perfect skyline, and there's no difference in variation, which is completely impossible. We can never replicate that, even in a small scale laboratory experiment. We can never, ever, 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 ever have hot and cold particles create different densities variance with complete with making them completely equal. It's
It doesn't
impossible.
need to be. You just need averages. There's a reason why the picture is a little blurry. And it's because there's atmospheric distortion. And that atmospheric distortion precisely comes from the fact that you have, not perfect layers of hot and cold and different densities. Like there's a little bit of wiggling.
So you're saying that when we look at a horizon, when we look at the sky touching the ocean, right? Is the sky actually touching the ocean?
The sky is not like a thing, but like it appears to look like it is. Yeah.
So we obviously know that the sky isn't touching an ocean. That is due to
I don't know what you mean by like. What do you mean by sky touching the ocean? Like it looks. So when you look
out,
like it is, right?
When you look out into the. So if we're out in the daytime, right, we look up, right? Sky's blue. Now we look out into the ocean, right?
By the way, and before we continue, I just want to show you that I pulled up the Earth curve calculator. I punched in the numbers: 2,820 meters for his height, as per here. This is from peak to Finistrel, 2,820 meters. And then the other one, Peak Gaspard, is he says it somewhere, 4,102 meters. So I punched that in. Sorry, I punched in a slightly shorter. We can punch in 4,102. And 443 kilometers. And even at standard refraction, you see a little bit of the top.
Wait, so can you convert that to miles, feet and miles, real fast?
I guess I'll just do feet and miles. There we go.
Okay, so
275 miles, 9,251 feet, 13,458 feet.
And how much refraction? 0.4. That says?
I just clicked on standard.
Oh, standard refraction, and that is hidden still 12,000 feet below the curvature with standard refraction, and it actually wasn't.
It's above curvature. You can see it above the horizon. You just can't see the bottom 12,680 feet.
Yeah, and we can clearly see like the first 2,000 feet of the mountains.
Oh, how can you clearly tell that it's the first 2,000 feet of the mountains?
Because we have the bottoms of the mountains, because we aren't Superman, right? So the bottoms of the mountains are going to.
So you're telling me clearly from this photo, we can tell that's the thing that we're looking at, by the way. Clearly, that's the top 2,000 feet. Clearly.
No, that's a very distorted image. That isn't even the image.
This is the image that won the prize, that won the Guinness Book of World Records.
No, if you scroll up, that's the image. That's the image right there. So you're completely wrong. And tell me.
I mean, this is so then which mountain is the mountain?
It's very hard to see in that one. It's actually not the one to the left. It's not the one to the right. It's actually in the middle because it's farther away.
So you're telling me that it's maybe clearly that right there, clearly 2,000 feet.
Yeah.
How do you know that that's 2,000 feet?
Probably because the landmass. You see those two landmasses underneath them? The landmass,
like that mountain there, that mountain there.
No. If you move your cursor down to the left, yeah, those are about 70 miles away.
What are we looking at? That's just like a line of black.
No, not that. I'm talking about. You see the landmass that's closest to the camera, right there.
Yeah,
down
like this stuff here.
This is why I need
to the camera.
I'm talking when you were zoomed in. Those weren't even in the frame.
We're zoomed in. So
those two landmasses. Listen, you have a PhD. Those two landmasses.
That black thing there.
Yes. Why is that sitting higher than the one that's closer?
Wait.
If the Earth is a curve.
I don't even know if that's a landmass.
You don't even know if that's a landmass?
What is that black blob there?
How about you go on Google Earth, right? Go on the maps, go to that exact location, or I think it has the line of sight down below, and tell me that's not a landmass.
I think it probably does. I don't even know what it is. So
whatever it is, it's sitting higher than the one that's closer to it. When we're on a curve, it should be following the curve away.
Sorry, this is sitting higher than what?
Sitting higher than the one that's closer. Do you see that thing?
This one.
Yeah, it's sitting higher than that when we live on a globe, dog.
I mean, depending on the relative height here, the height of the observer, and where these two landmasses are, of course this can sit higher. In the same way that if you're looking, and by the way, that's That's true regardless of what shape the Earth is. If you're sufficiently high, further things will look like they're higher up, right?
No, because we have to understand if you take a boat 3 to 5 miles out, right? You guys claim, the curvature of the Earth will block it bottom up. That's over 70 miles. So the Earth's curve might not be as, sufficient to compare to the 24,000.
That 70 miles is 1 degree, by the way, roughly.
Yeah, like 1.035, something like that.
Yeah, so it's like 1 degree.
Yeah, but you have to understand 1 degree compared to the viewing angle is going to make a major difference over 70 miles. I can explain. If you're looking at my camera, right? Give me a second. So if we have like an angle, right? Let's say this is how sunsets work. This is how everything perspective works on a flat Earth. If we have the sun that's right here, we draw the hypotenuse, okay? Then we draw the base and then make the right. Let's say the sun moves farther away. What is going to change this angle right here?
All that changes is the angle, and it'll never go below 0, by the way.
So now explain to me when angular resolution in the topic that an object becomes unresolvable based on angular resolution. What does that mean?
That sentence didn't really make any sense. If you want to rephrase it, I can try to interpret what you're saying.
So you're telling me when I said an object becoming unresolvable, right, due to angular resolution, doesn't make any sense?
Oh, no, I just didn't understand the order of the words that you said.
Oh, interesting. But
there is something called angular resolution. Angular resolution is really a thing. I don't understand how that means that you wouldn't see the bottom half of the sun, but you would see the top half of the sun during sunset. But whenever we shouldn't pivot, by the way, right?
No, I'm not. This is the comprehension skills, because a lot of people are so dense to concept, you'll think that I'm pivoting, but this all connects if you just listen. So if you understand that angular resolution basically is just everything until it hits the 180 linear. If anything goes below the 180, the horizon, it will then become unresolvable. That's not
what angular resolution is. Angular resolution is just a limit to how far away something can be, or how small the angular size of something can be before you can't distinguish it from another thing. But the point is that this has nothing to do with the height above the horizon.
It completely does.
To be clear, how high do you think the sun is?
We would need to know the full size. We need to know the full shape. But if I wanted to make my own theory, I'd have to use trigonometry. So that would mean I would take a point at zenith where the sun is, 90 degrees above the Earth, and then, well, not 90 degrees, and a straight line above the Earth, and then we could take the point where I'm standing on, right? And then we, like I was saying, draw a hypotenuse, and we do the good old SOHCAHTOA, and we can basically get a baseline on at least how high it has to be.
Yeah, so how high would you get?
I don't like making a direct claim, but I would have to say around 4,000 miles or a little bit higher.
So if that were the case, let's suppose that it's 4,000 miles, give or take. And how far away do you think the sun is at midnight?
At midnight, that it wouldn't change its altitude. It's just moving farther.
How far away is it along the topographical plane?
I don't know. I've never did.
How far away do you think, say, India is from the United States?
I don't know the exact number. Just let me know.
Okay. Would you trust it if I just Googled?
Yeah.
How far is India from, say, New York? We can do Texas or whatever, but come on. Okay, so it is the distance from New York to India is somewhere between 7,300 and 8,000 miles. Okay. So if the sun was to be 4,000 miles up, that's best case scenario, 4,000 miles up. If it's higher, it gets worse. And best case scenario, India's 8,000 miles away. That's the furthest it can be from New York. And by the way, India's about the opposite side of the Earth on, like, India's like 12-hour time difference, right? So when it's midnight here, it's noon there.
According to your globe Earth.
Well, I mean, that's the time zone stuff, right? Like, time zones are real, and we can check those pretty easily by calling somebody.
Well, time zones are placed and are due to the motions in the sky. So yeah.
Well, I mean, I understand that that's what you believe, but the point is that when it's midnight in New York, it'll be like noon in India. We agree on that? Like, the sun will be directly overhead in India?
when it's dark in New York, it will be light in India. It doesn't matter what time it is. Time is a social construct created by humans to track what has happened and when.
Can you just be intellectually honest and just like agree with me? Like, yeah, when the sun is down at midnight in New York, the sun will be up directly overhead.
Yeah. Okay.
In India.
I'm agreeing with you. Yeah.
Okay.
Yeah.
So that means if your claim is true that this is an angular resolution issue, then we should be able to see that the angular resolution of the sun should be or the angular position of the sun above the horizon should be below the angular resolution limit of the human eye. But if if the sun is 4,000 miles up at minimum and India is 8,000 miles away at maximum, that means that you're getting an angle of pi over 6. Pi over 6 is like 30 degrees. So you would have that sorry, that's not right. It's a little bit different than that. It's the tangent of or the arctangent of a half. And we could go and calculate that. It's probably about 1/2 because that's what the tangent is. But the point is we can compute the angle there. I'll pull up a calculator and we can do it right now. And you'll see that it's like 15 degrees above the horizon or something like this. That's where the sun should be at midnight. So
based on what? The assumption that the Earth is red?
Based on the height of the sun that you gave.
Yeah, that was just the claim. I can't. Whenever we talk about a light source in the sky, we can only observe. That's the first step of the scientific method.
Right. So sorry, it would be 26.5 degrees above the horizon. So in order to get a what's your claim?
Can I say something first? Everybody in the comments and everybody that's on Blitz Live, did you guys know the distance from the sun to the Earth has changed 9 times throughout history? It was first like 200,000 miles away, then it was 400,000 miles, changed to 3 million. Now we're at 93 million. So tell me how we measure distance.
So look.
Yeah, I could say that.
Yeah, you were poisoning the well. Okay, I'm glad we agree. So yeah, I mean, as science gets better, we get more and more accurate numbers. Great.
With scientific method.
what is the angular resolution that you would say the human eye has?
Like the angular resolution, like how far we can see?
No, the angular resolution.
Like it would have to be around like 160 to 180, depending on your eyesight. Like we
160
see
to 180 what?
Degrees, because our eyes are in like a half semicircle. Like what?
Okay, so you're saying that we can see. So what? So you think that the smallest thing that we can see is 160 degrees across?
Oh, that's what you're saying. I thought you meant like our field of view. No,
I was asking about the angular resolution. Is the word I used?
Yeah. I don't know an exact number. I'm okay at saying I don't know.
Okay,
but I know how it works. Do you know the exact number?
I think it's like an arc minute, but I can pull this up.
Why did you ask me?
Because my point is I don't think that you know. Yeah, okay, it's about 1 arc minute, 1/60th of a degree or so. So if it's 1/60th of a degree, we can figure out how far the sun would have to be for it to be indistinguishable from the horizon, how high up the sun would have to be for it to be indistinguishable from the horizon when it's midnight, right? In New York. So we can put X there. We can say that we want this to be equal to 1 arc minute, which is 1/60th of 1 degree, which is 1/60th of sorry, 1/8 pi over 180. There we go. And now we can just solve. Let me show you what I'm doing, just so that it's not completely in the dark. So we want.
So you're
calculating. This is the height. I'm calculating the height of the sun to the point where how high the sun would have to be so that it becomes indistinguishable from the horizon using human eye resolution. So when it's 8,000 miles away, how high would it have to be so that we can't distinguish it from the horizon, right? So it's 1/60th of a degree. A degree is pi over 180 radians. That's what a degree is. And so now we can just solve.
Wait, aren't you missing something?
No.
So we're just going to act like the sky doesn't ramp down and the ground doesn't ramp up.
So
the farther away it is.
So it would have to be 2.5 miles up.
You see how
2.3 miles up.
Ignored me, guys?
Well, because you said something dumb. The sky ramps up.
So
the ground ramps up. I'm sorry.
I said the ground ramps up and the sky ramps
up. What does that mean?
So this is this is called being intellectually dishonest, everybody. As you
It's
know,
not
the
called
farther
being
you look.
intellectually dishonest when you dismiss something that's intellectually dumb.
No, you just pulled up an equation on the altitude on how high the sun
Yeah,
has to be.
I did the math for a triangle.
Yeah, when you don't know how high the sun is, or when you don't know the
I'm
shape of the
solving for the
sun.
height of the sun.
Yeah, I know. How are you going to solve for the height of the sun when you can't isolate it?
I just did isolate it.
So
I
you're
isolated
telling
the
me,
variable
okay,
x.
tell me the 7 steps of the scientific method that you just took right there.
I'm not using science. I'm using math. I'm using geometry in particular.
Well, the only thing you can do is an observation, right?
The observation is that we can't see the sun at midnight when it's over India.
Yeah, and
That's
then
the
that's the only
observation,
thing you
and then I'm
can
just
see.
doing math based on that observation. This is basic trig.
Yeah, it's basic trig, but you have to understand, you have to know how big the sun is first to, like, what if
Not
the sun
really.
is,
I'm just assuming that the center of the sun is indistinguishable from the ground using our human angular resolution of the human eye. So at this height, this is the height at which something that is at height x, for example. I'm solving for the height x, where the center of that thing at height x is indistinguishable from the ground.
I understand I understand when you first started saying, bro, how high the sun has to be for it to be, converging with the horizon, my brother. I understand.
It's not converging. It's just angular. You just can't distinguish the two using angular resolution.
So now now I'm going to say it again, brother. So why does the flat horizon, when you look out into the ocean, create the apparent convergence that the sky is touching the ground? And if the sky and ground
The
don't
sky
ramp
is
up.
just everything above the ground. So if you see the ground, then the stuff above it, where the ground isn't, you'll see sky.
Yeah, but if we look directly in front of us 2 feet, we don't see a horizon, do we?
The sky touching the ground isn't the horizon. That's just where we can no longer see the ground. That's where the horizon is. It's where the ground is no longer visible.
And in your belief, the horizon is created by the curvature of the Earth, right?
Well, yeah, and then there's of course optical effects because we don't live in a vacuum.
Yeah, so that would mean that the sky isn't actually touching the ground. It's apparent.
The sky isn't a physical thing.
I'm not
The sky
saying
is just
that,
where the ground isn't.
yeah, but the sky, so we don't have an ionosphere and 7 different layers of the atmosphere? What are them?
Those are layers of like air molecules.
So what's
not
the
necessarily
sky?
air,
Why is the grass green?
You know that there'd be a sky.
Blue?
You know that there'd be a sky even if we lived in a vacuum, right? It would just be black.
Yeah, no shit, because it's
So
nothing
the
but
sky
the
has
ground.
nothing to do with like the air. The sky is just where the ground isn't.
So when we look up, right, and
Mm-hmm.
we see blue, and we look down, we see green. What is the blue?
The blue is the air.
So when we see the blue touch,
Laughing like a joker won't make your argument look better, by the way.
honestly, it's honestly funny. But whenever we look at blue, right, and we look at the ocean and we see the flat horizon, what's happening?
What's happening is that you can no longer see the ocean beyond that point. The ocean is obstructed. The ocean beyond it is obstructed by the ocean in front of it.
Listen, man, there's nothing I can say to get to you.
You're right. Now, hey, have you heard of Qantas Flight 28?
If we draw imaginary lines on an imaginary depiction of our land masses, then we could say whatever we want about them.
Have you heard of Qantas Flight 28? This is a real flight. It's currently in the air.
I was already watching when you bring this up.
Okay, what's the response?
The Gleason map, the farther you get out to the our ice wall, it's distorted because it's a projection of the globe.
So
right?
what you're telling me is that the flat Earth map is not accurate because it's a projection of the globe?
No, it's because it's distorted the farther you get to the ice wall.
Do you have so look, if the Earth is actually flat, you don't need distortion to represent it on a flat map.
So tell me how they made the Gleason map, please.
Well, the Gleason map is an azimuthal equidistant projection,
Equidistant
right?
projection, the same one that they use in flight, the navigation systems and airplanes, actually.
Sure. It's not necessarily always from the North Pole, but sure. I'll grant you that. It's not really relevant. What you do is you basically just take a globe. You can put a puncture at the bottom and you smear it out. There's some more math involved, but that's roughly it. So you agree that the Gleason map does not accurately represent the shape of the Earth?
I would say it doesn't accurately represent the depictions of the land masses.
Okay, so would you say that Santiago is the same distance from Sydney roughly as New York is from JFK? Or sorry, as New York is from Tokyo?
Yeah, roughly.
Okay, no, this is actually huge. And so if I found more flights that were equidistant between north and south, it sounds like that you'd probably, that are equal time roughly. Again, they're not going to be exact because obviously there's always wind and stuff. They might differ by half an hour or something. But if I found similar pairs of flights all across the northern and southern hemisphere, and you would agree that the distances are the same, right? If the flight lengths are the same, flight durations?
I mean, they'd have to be.
Right, and so that would mean that distances in the northern hemisphere are the same as distances in the southern hemisphere.
Yeah, but where are you going with this?
Well, where I'm going is that you can't make sense of that on a flat Earth.
Based on your depiction of the model of the Earth.
No. This is a geometric fact, right?
No, because we have numerous flights where they are not consistent with the ones before them because
Give me an example.
Ducks. Give me a second.
Example of a flight that's not consistent with the globe. I'll wait. Try booking a seat on QF28. Okay. I'll try booking a seat on QF28.
I think it's Johannesburg, Sayo to like London.
I don't know what Johannesburg, Sayo, is that a city?
I'm gonna take a picture of it. I'm gonna show you. Here's actually the same flight I was talking about. Those are the names of them. I don't know if you can see them. One second, I could just type them. Johannesburg, genius. Yeah, I know. But see, the thing is, there's one second. I can explain it. Just give me a second. So because I'm looking at I'm gonna go look at the map. It's Johannesburg to Sao Paulo into London. So
Sao Paulo. So Johannesburg, I don't know. Oh, in Missouri?
Yes, I think. And then they did an emergency detour to Sao Paulo. And
Sao Paulo.
And then, isn't there like a squiggly line above the A?
Yeah. I don't think it's anyway. So you're saying they started in you're saying they started in Missouri.
And they landed in Sao Paulo, and then they went to London, and that's a straight line on the flat Earth, but it's impossible on a globe.
Wait a minute, hold on. What flat Earth map are you using to show that it's a straight line?
If you just look at the map, bring it up.
Bring
up the map.
I thought we agreed that the Gleason map was just a projection of the globe.
No, you weren't listening to me.
So which map are you using?
I said pull up any fucking map. Pull up any map that is a consensus to be true.
Okay. How about this one?
Bro, this dude is so funny, bro. Oh my lord. But bro, why did you pull up a globe, dude? That's not what I was meaning.
Because it's a map that's consensus to be true.
I meant a flat. Listen, dude, I meant a flat Earth map, bro. I understand that. But listen.
All right, which flat Earth map do you want?
Just pull up the Gleason map, man, because I'm talking about the outer edges of the Gleason map are distorted. So Australia.
So Sao Paulo is part of the outer reaches, isn't it?
Yeah, but not as much as Australia would be.
Hold on, I'm pulling it up.
The farther you go out, the more distortion there is.
Come on, I want a high resolution one, not like one of these crappy low resolution ones. Okay, is this one okay? Okay, this one's decent. Okay, here I have your Gleason map. Now, what am I looking for?
So
So
if we go zoom in on the America,
sorry, I want it to be.
And then Missouri's down there by.
Give me 1 sec. I'm just gonna find one that will show my cursor because for some reason that one's not showing my cursor. Will this one show my cursor? Come on.
Yeah, Johannesburg is not in Missouri. Yeah, I didn't
Where
think
is it?
so.
Where is
I
it?
didn't even know.
Well,
I
there is a Johannesburg in Missouri.
Yeah, I don't know. I'm about to look it up.
Oh,
I
okay.
just
So
know
then
the
how can
flight.
you know that it's a straight line on the flat Earth map if you don't know where it is?
Oh, because I previously remember talking about this and bringing it up. Like I have a lot of things in my notes because I tend to forget things, and I have basically like topics and stuff, and then we go look over the topics and stuff, and normally when we look over them together, we both realize. But yeah, I don't know. I mean, maybe you should just
So I did.
wait, look.
I googled Jonesburg. It's in Montgomery County, Missouri.
I mean, yeah, there's also probably Martin Luther King Drive in every county too. But
How do you? There's one in Louisiana.
I don't
Are
know.
you
I'm
talking
gonna
about
have to-
Johannesburg?
Yeah, it's Johannesburg.
I think that's in South Africa.
I have it. I don't know. You probably can't read my box. But those are 3 flights.
Well,
My notes.
what's the city called?
Uh,
Look on my screen. Is it Johannesburg?
yes,
Okay, Johannesburg. Great.
that's it.
Okay, so we'll look here. So Johannesburg, and so what's the flight path?
So it goes to Johannesburg. It's supposed to be go to Johannesburg to London, but they made an emergency detour to Sao Paulo.
Sao Paulo. Right. Sorry, one sec. Let me just get my cursor going again. So then I can point to things. Okay, this shouldn't. Okay, fine. So Johannesburg is here, in South Africa, and then they went to Sao Paulo, which is like over here, and then they went to London, which is like roughly here. How is that a direct flight on a flat Earth?
No, compare that to the globe.
Well, on a
So they're
on a
flying to
flat
London.
Earth, on a flat Earth, it doesn't make sense either.
So listen. Just let me explain.
Johannesburg to Sao Paulo to London.
So that's what I'm. Listen. They are
So
flying to
we agree
London.
it doesn't make sense on a flat Earth.
No, we are flying to London, but they made an emergency detour to Sao Paulo.
Yeah, so they go from Johannesburg here to Sao Paulo here.
Now compare that
London
to
here.
a globe. Compare that to a globe. Those 3 things actually happen. You can go look at the flight.
Okay, so how do I find that these 3 things happened? By the way,
Just look up the emergency landing to Sao Paulo when they were flying to London from Johannesburg. I'll give you
emergency
that.
landing, Sao Paulo, Johannesburg. Okay.
Anthony, I will admit I am not the best on geography because I never took the time to analyze every single thing. But I can tell you,
I find on r/flat Earth, Johannesburg to Sao Paulo direct flight. Oh, that's a direct flight. No, we want the emergency landing. Okay, that's a emergency landing Sao Paulo, Johannesburg, London, right? That's where it was going.
you guys are claiming that I didn't know geography when me and Blitz were both trying to figure out which Johannesburg, bro.
Well, you said Jonesburg. I know where Johannesburg is. So I'm actually not finding any flights that redirected from South Africa to Brazil while it was on its way to London. I'm not seeing any of those. And I can show you what I'm looking at. Right, this is the search. Emergency landing, Sao Paulo, Johannesburg, London. And there's no record of a single emergency landing involving 3 different cities in a direct sequence. So actually, I guess we should probably put it in the other order. And then we can go, like, we're not going to trust the AI overview, of course. A British Airways from Johannesburg to London was forced to make...
Wait, if you click that link right there, that's the actual cited source. Do you see that?
Yeah, but this is saying a separate incident, a Boeing cargo plane made an emergency landing in Sao Paulo after catching fire mid-flight. But that doesn't have to do with Johannesburg and London, right? This was on a flight that was going from Johannesburg. We can look here. This was going from Johannesburg. No, hold on. So let's see what this says. No, this doesn't say anything about Sao Paulo. This is going from Johannesburg to London. And then there's a whole bunch of spam stuff. Hold on.
It's on my screen right now. I found it, but 1 second.
Your screen is super blurry.
I know.
So there are overweight landings in Johannesburg. From Johannesburg to London, this is a flight that... Where did it land? Oops. It landed back in Johannesburg, so it took off and then it landed back in Johannesburg. I'm not seeing anything that you're seeing, right?
1 second.
It says, while the prompt mentioned Sao Paulo, the specific incident was between Johannesburg and London. In a separate incident in November 2024, a Boeing cargo plane made an emergency landing in Sao Paulo after catching flight mid-flight. But this time, this was not a. We can actually go look at the source.
Well, I encourage this. I remember talking about this flight. I remember finding it.
It seems like it's made up.
No, it's definitely not. It's definitely not made up. I don't know.
I'm not seeing anything about it.
I can find. Yeah, let me find the flight number. I'll find the flight number. Just give me a second.
Okay. Let's see if we can just find anything. So there's no record of a recent emergency landing specifically from Johannesburg to Sao Paulo. Oh, he left.